Assalamualaikum. Hi everyone. Welcome to our discussion session today. My name is Nadira binti Azman, number E21A0614. I am proud to be a member of Group 5 for the subject Biological Diversity ENT 3322. I am the moderator for this discussion. Before we discuss our topic, I would like to say 10,000 thanks to our lecturer, Dr. Nalato Anis binti Amaluddin, for imparting her knowledge to all of us. Thank you for guiding us on the setting journal to explore biological diversity subject. Okay, we will start with Muhammad Sazwan bin Rosli, number of species. Can you identify the number of species from the plot data in the Excel sheet?
Okay, thank you, moderator. My name is Muhammad Shazwan Berusli, and my number matric is E21A0555. Okay, wait a little bit. Number of species. Number of species refers to the number of species in an area or ecosystem. What will measure the number of species? Species richness is a measure of the number of different types of species in an ecosystem. A large number of different species in a habitat represents a higher species richness and an overall more diverse ecosystem. The first part is the number of species. We have 900 species of trees. As you can see, the calculation of the number of species is divided into 4 plots, which are plot 1, plot 2, plot 3, and plot 4. For the plot 1, the total number of trees in the plot 1 is 147, and the total number of species in the plot 1 is 50. Second is the total number of species in the plot 2 is 220, and the total number of species in the plot 2 is 44. Third is the total number of trees in the plot 3 is 157, and the total number of species in the plot 3 is 68. And lastly, the total number of trees in the plot 4 is 132, and the total number of species in the plot 4 is 22. Lastly is total number of species total number of trees in 900 trees. The total number of species is 87. That's all from me. Thank you.
Thank you for Muhammad Sazwan bin Rosli for sharing your instinct on the number of species. Second, Nabila, what data can be calculated based on diameter at breast height, DBH, in centimeter?
Thank you for asking, moderator. Here I would like to share with you guys the data of diameter. Can you guys see my screen?
Not yet. No.
Yeah.
Yes. Okay.
Yes.
Okay, first, DBH is a standard of expressing the diameter of the trunk of a standing tree. This is DBH for plot 1 that we got from every species. This is DBH for plot 2 for every species. This is for plot 3, and this is for plot 4. Diameter DBH is very important because for calculating height, basal area, and WS in kg was use the DBH data. That's all from me. Thank you.
Thank you to Nabila for providing information on the data that became calculated based on DBH. Next, Ishak and Farid Iskandar, can you uh, provide the calculate result for base area, IVI, and above ground biomass for the plot data?
Okay, thank you for moderator. Okay, I want to present. Okay, my name is Ahmad Farid Iskandar bin Ahmad Rizwan. My metric number is E21A0442. Okay, before I answer that question, you all must be wondering what is a basal area? Why do we need to know the basal area? For everyone's information, basal area is a forestry and ecological measure that refer to the cross-sectional area of tree trunk at breast height in a defined area, usually expressed in square feet or square meter per unit or square centimeter per unit land area. It is an important metric used to assess the density and productivity of forest time. Okay, we can see in the data, for example, in plot 1, basal area, for formula, the formula is basal area is 0.7857 time dBH square, okay, in unit centimeter square. Okay, this is the same formula next. Okay, in plot 2, the same formula, plot 3, same formula, and plot 4, same formula. Okay, that's all for me. Okay, thank you.
Thank you for moderator. My name is Muhammad Ishaq bin Zaki. I think it's 21A0. For above ground biomass is defined above ground standing dry mass or leaf or dead matter from tree or shrub left one express a mass per unit area, typically mgHA minus 1. For calculate WS per kilogram plus WB per kilogram plus I kilogram plus is result biomass. That's all for me. Thank you.
Thank you for Ishak and Is for sharing your calculation of basal area, IVS, and above ground biomass. Next, Kurator Ain, can you show the graph of our plot data and does the graph exhibits a reserved J curve pattern? If not, why is that the case?
Okay, thank you to the moderator. Wait a minute, I want to share my entire screen. Okay, you guys see the screen? Okay.
Yes.
Okay, for the reverse J curve, the table is about the number have the diameter that's small or big. And okay, to get the DBH, the reserve J curve, we need the DBH from the all plot and arrange it in ascending order. So from the smaller to the big number. Okay. Then get the table which is here. Okay. The histogram show that our data in the mid of DBH is get the reverse J curve. Yeah, this here. It means there are a lot of trees with the smaller diameter than the biggest diameter. Then this can tell that the forest in regeneration phase. So the trees with the biggest diameter be the mother trees in this forest. If a revisit is done at the same area, it can show the trees with the smaller diameter can be the mother trees in that forest in the future. Okay, that's all from me. Thank you.
Thank you, Curator Ain, for presenting the graph. Next, Aiman and Jana, let's discuss the value of Shannon diversity, Simpson diversity, and daylight from the available data.
For the Shannon index, calculation will perform for all plots from plot 1 to 4 using the Shannon linear diversity index formula. Therefore, I will explain one of the 4 plots in more detail. For example, in plot 4, while for the other plots, the calculation perform the same. So we need to find PI, ln PI, H, and effective species. And lastly, as you can see from the Shannon result, the highest number of effective species is in plot 3, which is 50.012, while the lowest number of species is in plot 4, which is 14.474. That's all from me. Thank you.
And next, we will define for the Simpsons diversity index. Following to display the result, we will use this formula, which is D is Simpson diversity index total value, and then there is a total individuals for each species over here. And here is total individuals excluding one per species, and for this equation is for a potential species pair combination. And for the total individuals have been provided, and we only need to calculate the total individuals excluding one per species and potential species per combination. And for this equation, we just need to put the equal equation, put the total individuals minus with 1, and this equation we need equal. We need to total individuals times with total individuals excluding one per species. And then we all of the 4 plots will proceed with the same steps. So we need to calculate the sum total of the individuals and totals of the potential combination per species. And then the total individuals we get 147, and the total individuals excluding one per species is 146, because equal total individuals minus with 1. And then this we need to the potential species per combination, we need to times the individual's number of species and the individual number of species excluding one per species, and then we will get 21,462. And for the finalize the Simpson diversity index, to calculate this, we need to use the equation equal 1 minus the potential species per combination, and then divided by, sorry, my bad, I mean we need to 1 minus the total number of the potential combination per species, and then we need to divide it by the potential combination species pair itself, and we will get 0.96, and we average it into 96%. So it shows that the diversity in the plot 1 is a lot. So how we want to find out there is same species within the plot by using this formula, which is we need to equal 1 minus the result we get different species within the plot, which is 96% or 0.96, and we will get 0.05, which is there is a 4% species that is same within the plot. That's all for the Simpson diversity index.
Thank you, Jana and Aiman, for your insight on Shannon and Simpson diversity and relate value. Next, Aina Natisha, based on your calculate result, how would you like describe the qualification of the area? Are there any additional suggestion or analyze can you share? Isha.
My turn. Thank you, moderator, for that question. Based on the number of species found in each plot, environmental conditions play an important role in influencing species diversity. Among them are soil conditions and forest thickness. For plot 2, we have found a total of 44 species highlight the role of soil condition in promoting biodiversity. Soil factors like pH, water absorption capacity, and structural suitability are crucial for supporting diverse plant life, especially among tree species. The plot with the least amount of species is plot 4, which is only 22 species. This lower diversity is likely due to less favorable soil conditions compared to the other plots. Factors like less fertile soil, nutrient deficiencies, or unsuitable pH levels could be limiting the variety of species that can thrive there. In plot 3, remarkable 58 species were found, suggesting that dense forests or adequate plant cover favor greater plant diversity. This environment provides both protection and support for a rich variety of species. Lastly, plot 1 has a total of 50 plant species identified. The species in plot may be impacted by reduced plant discover or human disturbance. Replanting activities or conservation activities need to be implemented ecosystem structure. I think that's all my answer for that question. Thank you. Thank you.
Thank you to Aina Natisha for your assessment of the area condition. Lastly, Rosanna, as an SEN student, are there any suggestion or reason that can be explained for conservation effort to enrich the area into the healthy ecosystem?
Thanks to our moderator, Nadira, as a SCN student for steering the head of the forest Tasik Bandar ecosystem requires a comprehensive approach. Firstly, implementing sustainable logging practice is imperative to minimize ecological disturbance. Emphasizing selective logging and avoiding clear cutting can protect the habitat structure, allowing flora and fauna to thrive. Secondly, active reforestation initiatives should be prioritized. Planting native species help restore the ecosystem natural balance and provide essential habitat for diverse species. Involving local communities in this initiative fosters a sense of ownership and ensure long-term sustainability. Furthermore, engaging in eco-friendly tourism practice, such as designated trail and low-impact recreational activities and minimize human impact on the area. That's all for me. Thank you.
Thank you, Rosanna, for providing your perspective as a SEN student.